Hi and welcome to the Home Assistant How-To with Bearded Thinker. Today we are going to be protecting our evil bunker from the radiation. We'll start in a couple of seconds. Before we begin today's episode, I really would like to thank all the members who have joined my channel. Thank you. Your support means a lot. And now let's get back to video. Today we are going to be working with the radiation sensor, our DIY radiation sensor that is made from the Geiger Muller kit that you can buy on the internet. Well, this kit is ready-made, but it's ready-made and it does nothing in terms of integration. That's why we will be adding ESP32 boards and making this sensor work with our Home Assistant. As you can see on the screen here, I have this working in my setup. It's been working for some time now. Unfortunately, it also didn't work a long time for me, so I spent a lot of effort, made the kit itself work because it didn't work out of the box, and I managed to integrate it inside Home Assistant. Building this kit and making it integrate with the Home Assistant is very simple and anybody can do it. I also use this kit to talk with my kids, especially my younger kid, about the radiation, what the radiation is, why there is radiation in the nature, why do we use radiation, but also what happens if the radiation levels are too high. My friends, on the other hand, they tried to stop me from recording this video, and the reason for that is that in January I made a video about COVID-19 and then we had pandemic. Later on I also made a video about the USGS or US Geological Service earthquake sensor. Then we had a pretty strong earthquake in Zagreb, and now I'm making radiation level counter. So what's next? Okay, as I said, I like building fun stuff. And I think that this radiation level can be a gimmick for your Home Assistant, just for you to have fun with. But on the other hand, it can also help you detect when the levels are too high. Please bear in mind that this kit is a DIY kit. It's not a precise instrument, definitely not a precise instrument. You cannot use it for any professional use, and please treat it as such. Now let's get to the fun stuff and see what we need for this and how we can make this work inside Home Assistant. This video will be divided into 3 major parts. First part is connecting the kit itself with the ESP32 and making sure that the kit works. Second part will be integrating it with the ESPHome. And third and the last part will be something that is optional, but I really do recommend that you do it before you commission this Geiger Muller counter, on how to calibrate the kit itself. Let's get started. So today we are going to be working on this Geiger Muller counter. This is a very simple kit that you can buy online. I was a bit unfortunate with mine, but I managed to get it working at the end. How this works is you provide power here or here, and I think it's a 5 volt. You can use the supplied cable that can be connected with the USB, so you provide USB power here. You have to calibrate it. The process of calibration of the board I'll show at the end of the video. You can check the index of the video. I will put a timestamp for the calibration of the video. When there is radiation itself passes through this tube, agitates the gas inside, and it starts triggering, let's call it like that, discharge inside the tube. And when everything is agitated, you get this converted to sound, the ticking sound from the radiation counter, you know, from the movies or games. And the second one is the strobe of this LED. But we are not interested in that. There are also some additional outputs here. This one can be used to connect this to a PC, for example. It's a 3.5mm audio jack here, and then you can use that thing to convert the signal, but we will be using those 3 pins here. This is the ground, 5 volts, and V in or V out, I don't know how you would call it. We will use this here to intercept the signals. So what are the things that you will be needing for this project? First of all, of course, will be this board. But besides this board, we will be using this ESP32 board. You will also need 3 Dupont cables, a USB cable to connect the board to the PC to provide power, but also used to program this board when we make our initial sketch. All the later updates will be handled over the air, OTA. And of course you also need power brick or something to provide power after you disconnect this from a PC and use it just to provide power to this one. Calibration video can be found at the end. So the question now is, how do we connect this with our Home Assistant? The easiest way, of course, is by leveraging the ESPHome, and this is how I will do it today. For that, as I said, you will need ESP board and you will need some Dupont cables. First, let me disconnect this. The second is the warning. So the warning is in regard to the minus and plus here. Those lamps work on voltages between, I think, 350 to 400 volts. So you should be careful not to touch those two plus and minus at the same time, as you may get slight discomfort for such a high voltage. I did try to measure it and it was never 350 volts for me, but maybe there are some discharges and things like that, so yeah, I will not be playing with that. Now we have 3 cables. 2 of them will be used for ground and 5 volts. Move this closer and I'll add those 2 cables on 5 volts and ground. So yellow is 5 volts and orange is ground. Then we have to take cable here, and as I said, yellow is 5 volts, it needs to go to VCC, and orange is ground. This is the pin next to VCC. So we have VCC and ground. In regard to VIN, or input or output pin, I'll put this, I don't know what color this is, brown, or whatever this color is, and I will be utilizing port called SUP. I think that this is port 036. If I'm wrong, I will put the correct name of the port in the video subtitle. Okay, so for ESPHome 32, you can connect it with the VCC and ground to 5 volts and ground. This will provide power from the USB port to this Geiger Muller counter. And one cable needs to go from VIN to SUP here on the board. This is second pin from the top. We can test if everything is working by connecting the USB cable. I do have a USB cable. If we connect it here and connect it to the power bank, as you can see, the board is working. There is a ticking sound and we do see here red light. So the board itself is now working and the board is connected to the ESP. Disconnect it. Just a quick note, when I'm not recording, I really do not disconnect. I'm just pretending to be very careful to not burn something, but I'm not that careful. And now let's put the top back in. And this part of the video is done. From this point on, everything is prepared for us to connect this board to the PC. You need to have data USB cable, and next steps will be done through our Home Assistant in ESPHome.
Now that the kit is connected with the ESP32 board, what we have to do is we have to create this. Let me switch to my recording setup, and what we have to do here is we have to add board to our system. So how do we do that? First of all, we press the plus sign here. Let's give it a name. Let's select the device type. and we will be using this generic ESP32 firmware module. For the Wi-Fi, I'm using secrets file, so let me try and type here secret Wi-Fi SSID, and password is secret Wi-Fi key. Also, we can use over the air password. For me, this is once again secret OTA password. And let's continue. Let's press submit. File has been created now. Let's edit it. Our file is here. Let's fix the configuration here. I have some typos, and let's also add part for the kit that we need to make it work. This is okay. SSID is wrong. We need to remove this and this. Password also, this is wrong. We need to fix name. Access point we can leave as is. Next thing that I'll do is what I always do on my boards. I assign them a fixed IP address. Manual IP. Static IP 192.168.159. Gateway 192.168.1.1. and subnet 255.255.255.0. Okay, we will leave the captive portal here. I'll fix once again passwords. I don't know if you are using secrets file in ESPHome, but I sincerely recommend that you do so. So now it's time to configure sensor itself. We do it by typing sensor, platform. We will be using pulse counter. The pin on the board that we connected our VIN from the kit is SUP, S-U-P, and this is, as I said, GPIO 36. So pin GPIO 36. Name Geiger counter, although the correct name would be Geiger Muller counter. Update interval will be 15 seconds, meaning that we will be taking samples every 15 seconds. Unit of measurement, this is not a necessary field, but it will make everything more pretty. Let me copy this from the configuration I have on my main setup, because I really do not know what is the ASCII code for this. Accuracy decimals will be 4. And there is a filter. Type here lambda. Return x divided by 123.147.09236.0319. That is 123.147.09236.0319. The other way you can do the same thing is to use multiply. I will give you the example of multiply. Multiply. And you have to find the factor for the tube you are using. The J306 tube I'm using needs this multiplier 0.00812037037. So you can use either this lambda or this multiply. The results will be same. And let's save this. Okay, so we now have prepared our YAML file, and this YAML file needs to be uploaded to our board. Since this board is a new board, we do not have it still in our system. What we cannot do is we cannot use over-the-air connection. So let's press save here, let's press close here, and we'll click on these three dots and click on the compile. This will take a couple of seconds or minutes depending on the speed of your system. And this is finally done. Let's press on the download binary. And the binary is now downloaded. Next step for us is to upload for the first time firmware to the ESP board itself. In order to do that, we have to download ESPFlasher. ESPFlasher is an application or a program that you launch, and it's used to connect from your PC to the board, and it allows you to flash the board for the first time or until you get the over-the-air functionality up and running. And here is the ESPFlasher GitHub page. What you have to do is you have to go to the release section and download the version that you need. I need this one, ESPHome Flasher 1.3 Windows 64-bit version. Download this file, and after it is downloaded, just click it and start it. Okay, so this is the ESPFlasher. What you have to do now is you have to connect your ESP32 board with the PC, and after you connect the board, select here the port where the board is connected. Select Browse, bin file we just created, and start Flash. This flashing procedure is very fast, it will take only a couple of seconds. If you do see error like this, unfortunately it sometimes means that there isn't enough USB power or power from the USB cable, so you need to find a better power adapter. Let me disconnect here. Let's go back to our ESPHome. And here we now have our Geiger counter working. Let's show logs. Let's go now to configuration, integrations, and let's add new device here. (192.168.1). I think the address is this one. Let me type in the password. If I can remember what password is. And finish. We now have a Geiger Muller counter here. Let's go to Overview, Fun Stuff, and let's set it here. We'll go to Sensor, and here's our Geiger counter. From now on, this will be recording what is the current radiation level. And just to show you what are your options, I've also created in my setup a small automation. Let me switch the system. Of course, all my automations are also available on the GitHub. The link to my GitHub repository with my system setup is down in the description of the video. Let's go to weather, because radiation is weather. And here is the script I've created. What this script does, it checks the state of the Geiger counter, and if the numeric state of that Geiger counter reaches 0.9, I get a couple of actions. First action is, I'm utilizing here my script notify engine. I'm sending messages using this data template to who family, meaning me, my wife and the kids, with the title radiation level alert, and it sends as a message that radiation alert currently is, this is the state of the sensor, counts per minute, and the normal value is below 0.5. Well, I said normal. In about 2 or 3 weeks of using this kit on my setup, I didn't see value higher than 0.3, but to be on the safe side, I made it 0.5, and alerts are on values of 0.9 or higher. Tag ID for this is warning, sticky true, group weather, and the color is this one. Also the second action I do on this alert is I'm setting up 2 of my devices. Display me is in the living room and clock me is in our bedroom. I set the volume there to 0.5 or 50%, and then on both of those entities or media players I'm playing message radiation warning, current level of radiation is this, and normal value should be below 0.5 using tts.google.say. And if we look at this message, let's copy it, let's go to developer tools, let's go to templates. This radiation is interactive, meaning the values itself change on the current status of sensors. If I would trigger the message now, I would get radiation warning, current level of radiation is 1.0 and normal value should be below 1.5. And this is it for this Home Assistant how-to with Bearded Tinker. Remember, at the end of the video, after my bye-bye and farewell, I've added a video on how you need to calibrate this board. I really do hope that you like this video, I hope that you find it fun, and that you also maybe will be adding this board to your Home Assistant system. If you did find this video useful, or if you did find this video fun, please give me a thumbs up. If you still haven't subscribed, please subscribe and hit the bell button so you get notified on the future updates. If you have any kind of a comment or a question, feel free to leave the comment down in the comment section of the video on YouTube, but you can also find me on the Discord. Thank you once again for watching, and I'll be seeing you soon. Until then, bye bye and have fun! In order for you to calibrate this board, you have to remove this acrylic screen. Also be careful to not damage this tube. The tube itself has very faint text on it. It's J305 or 306. I think it's 306. I will put the correct name in the title here. Here is the plus sign. This is the negative sign. And usually you have here the date of manufacture, because those tubes here do have expiration date. In order for you to calibrate this, you will need a multimeter, and what we'll do, we'll connect this one to the ground. Plus will be here on J2. This is connected to the ground pin. You can use any ground you find on the board. Plus is connected to the J2. This one here has a J2 name. And we also need patch cable, 2 short plus side with this pin here. And the last thing that we need is we need to provide power here. Let me quickly bring the cable for power. Here is the power cable, and let's connect it to the power bank. And the goal is to have 6.5 volts between the ground terminal and the J2. If you do not get 6.5, if it's less or more, you can use this pot here, or potentiometer, to turn it either left or right to correct the values. So you need to have between the J2 and the ground 6.5 volts. As you can see, this board is already calibrated. Okay, I will disconnect the power. I will more or less remove everything. The tube goes back in. If you do break a tube, you can find it on AliExpress, maybe even the same shop where you bought this board, the spare tubes. Okay, and I'll put this screen here just to protect the board itself while we test. If I now turn the power on again to the board, as you can see, from time to time, every time I say something, we get a flash from this red LED. There isn't much radiation here, but there is some. This is what the final result should be. You will see occasional blinking red LED and sound from this buzzer.